module, you will learn about geometric mean. Given two numbers a and b, a number m can be found between them, such that a, m, and b form a geometric progression. Such a number m is called the geometric mean between a and b. Mathematically, the geometric mean between two numbers is a number that, when placed between them, forms with them a geometric progression. Let's now derive the formula to calculate the geometric mean. Let m be the geometric mean between two numbers a and b. Then a, m, b are in GP. This implies the common ratio m upon a is equal to the ratio b upon m. This further implies m square is equal to a into b, or m is equal to square root of a into b. Hence, the geometric mean between two numbers a and b is the square root of a into b. Let a be equal to 4 and b be equal to 16. Then, the geometric mean m between them is given by the square root of 4 into 16. This is equal to square root of 64, which is equal to 8. Hence, we can say that 4, 8 and 16 form a geometric progression. In general, we can insert as many numbers as we like between any two given numbers. Let us find n numbers g1, g2, g3 and so on up to gn between any two given numbers a and b. On inserting these numbers, the resulting sequence a, g1, g2, g3, so on up to gn and b forms a GP having n plus 2 terms. Let a1, a2, a3 and so on up to a n plus 2 represent the first, second, third, and n plus 2th terms of this GP, respectively. Now n plus 2th term is b. This implies a into r raised to the power of n plus 2 minus 1 is equal to b, or a into r raised to the power of n plus 1 is equal to b, or r raised to the power of n plus 1 is equal to b upon a. This implies that the common ratio r is equal to b upon a whole raised to the power of 1 upon n plus 1. Now, let us find the numbers g1, g2, g3 and so on one by one. g1 is the second term, which is given by a into r. Substituting the value of r, we get a into b upon a whole raised to the power of 1 upon n plus 1. g2 is the third term, which is given by a into r square. Substituting the value of r, we get a into b upon a whole raised to the power of 2 upon n plus 1. Similarly, the fourth term of this GP is a into b upon a whole raised to the power of 3 upon n plus 1. Likewise, the subsequent terms can be obtained. The last inserted number, which is the n plus 1th term, is equal to a into b upon a whole raised to the power of n upon n plus 1. As we have already seen, The arithmetic mean between two numbers is their average. That is, the arithmetic mean between the two numbers is a number which, when placed between them, forms with them, as we have already seen. The arithmetic mean between two numbers is their average. That is, the arithmetic mean between the two numbers is a number which, when placed between them, forms with them an arithmetic progression. Let's now see the relationship between the arithmetic mean and the geometric mean. Let A and G be the arithmetic mean and geometric mean of two positive real numbers, A and B respectively. Then A is equal to A plus B upon 2, and G is equal to square root of A into B. Now, let's calculate A minus G. This is equal to A plus B minus 2 times square root of A into B whole divided by 2. Now, A can be written as root A whole square and B can be written as root B whole square. This implies A minus G is equal to root A minus root B whole square upon 2, which is greater than or equal to 0. Therefore, A minus G is greater than or equal to 0. This implies A is greater than or equal to G. Thus, the arithmetic mean between two positive real numbers is always greater than or equal to their geometric mean.